So how do I insert into a heap if the heap's implemented as an array list, right? If we're using an array list, to store all the elements, then all I have to do is just simply do the add to the end method. So just simply use add item to list, and that will add the item I'm trying to insert to the end. And then I have to basically do this. I have to basically figure out what my parent is. Right? So I insert an item, figure out what my parent is using the formula. My parent is child minus 1 divided by 2. And then I just have this loop. While I have a parent, right? My parent is at a valid index, and my parent is bigger than me, while I am smaller than my parent, I swap myself and my parent. So, right? So here, right, I figure out what my parent is. My parent is at index 6 because it's 13 minus 1 divided by 2. So my parent's at index 6. I swap with my parent because my parent's bigger than me. And then I figure out who my new parent is. Right? So I set child equal to parent, and then I set my parent is equal to 6 minus 1 divided by 2. So 5 divided by 2 is 2, thanks to the magic of integer division. Right? So my parent is at index 2, and his value is 29. I'm bigger than that, so I swap. And now here I figure out my new parent, which is my index minus 1. So 2 minus 1. So that's 1 divided by 2 is 0. Am I bigger than my parent? No, sorry. Is my parent bigger than me? No, it's not. My parent is smaller than me, so I stop. It is a fairly straightforward algorithm. And removal is also fairly straightforward. So how long does this take, the insertion and deletion? So inserting in, how long does an insertion take? What's the maximum number of swaps I need to perform? The maximum number of swaps I need to perform is 1, 2, I insert the item, then I swap 3 times. So that's essentially 4 steps there. And notice that this tree is 4 levels, right? If I were to insert, say we had nodes filled up over here, and I inserted an item over here, there would be 5 levels to this tree. So and if I inserted it over here, it'd be 1 step, and then 1, 2, 3, 4 swaps, and then we'd be done. So that would be 5 steps. Basically, you have a number of steps equal to the height of the tree, which means that insertion, and we know that the largest tree of height h has 2 to the h minus 1 nodes. So we know that this algorithm takes log n time, O of log n. So we know that insertion and deletion are big O of log n, right? Best case, worst case, average case. Worst case scenario, log n. Best case scenario, you just add it, right? And you don't have to really swap anything, so it's 1 step. Okay, so that's the performance for the heap.